A very good morning to everyone. Welcome to In 5 Minutes. We are doing video on memory management, and in that series the next topic today is paging. Paging is the most vital concept of operating system which we need to understand. It is more of a logical implementation rather than a physical implementation, but this does provide a lot of advantages. So let's start with it. What exactly paging is? Paging mainly refers to pages which you have in a notebook. Let's try to understand that you have a book. Consider a book which you are keeping. Consider that book as an example. All the data, is it going to be on a single page? Obviously not. You'll be turning to the next page, then next page, and then next page. Paging is somewhat similar to this. Why the name given as a paging? The ideology behind this is when you have a data which is lying on some hard disk, and if that data is huge in nature, we will divide it in pages which are of fixed size. Logic is very clear. Take the data, divide in pages, and copy pages in memory. Even for that, memory needs to be logically divided in frames. Now, to visually understand the same concept, let's see this way. We have a data. That data would be broken into 4 pages. Let's call it data X. This would be page 1, 2, 3 and 4. Now, if we consider this as RAM would have a logical partition called frames. The logic behind this is very simple. If you think about reading. You're not going to read entire book, right? You will read entire book by reading one page at a time manner. Same way, suppose I require page 1. So page 1 would be brought to frame 1. This is just an example. Let's understand, being very clear, we are not saying that a page 0 would exist in frame 0. It can be anything. For instance, after this you went to page 2. This time maybe location 2 was occupied, 3 was occupied, you kept it in frame. So frame 1 is full, frame 2 is not available, 3 is not available, but to frame 4, what is available right now? I'll be copying page 2. So basic ideology behind paging is how you keep pages. As I said, from a physical storage, data is divided in pages. As you can see, that pages through paging system will be stored at some location which can be accessed by the user then. So the concept behind this is very simple, is dividing data into logical size pages and divide memory into logical size frames, and then when needed, copy needed pages in available frames in your RAM. Now let's understand this with a proper diagram. Now consider practical example what we are talking about. We have n number of process, or rather we have process X. That process has created pages, page 0, page 1, page 2, page 3, page 4, 5, 6, 7 up to n. That would be stored at a different location in available main memory, and this F0 stands for frame 0, frame 1, frame 2, frame 3, frame 4, frame 5 and so on. Out of which currently what is needed was page 0, page 1, page 2 and due to some reason page 7 maybe. Now these pages are kept at a different location into our RAM, and that would be used later on for the operation purpose. So the concept of paging should be very simple by now. We would divide available space into pages where if it is concerned to the storage or data or file or process, we will divide main memory into frames as it is concerned to store pages So ultimately we can understand this as a statement like pages will be stored in frames. Pages of data, frames of memory. So that's the basic logic जिसका आप बात कर रहे हो. That's what we are talking about, and this is what paging is. Obviously, it's a good idea to work with paging, especially when we'll be also doing swapping. We already did a video on swapping where we said dynamic linking was needed. Entire data will not be available. Only needed data will be transferred to the main memory and then removed from the main memory when no longer needed.